Welcome to today's webcast, brought to you by DataVail. I'm Stephen Fegg, Director at Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, Building the Modern Data Hub Beyond the Traditional Enterprise Data Warehouse. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if it's you. Now, to introduce our speakers for today, Chuck Ezell, Vice President and Practice Leader, Development, Tuning, and Automation at DataVail, and Jeff Carr, CEO and co-founder of SlamData. For more information on our speakers today, you can click on the arrows under their headshots. Now, before we start presentations today, we have a polling question for everyone on board. Are you using any of these non-relational databases now, or do you plan to in the next 6 months? And the answer options are MongoDB, Hadoop, MarkLogic, Cassandra, Couchbase, and please select all that apply. And while you take your time to answer those questions, if any of you are wondering who else is on board with us today, we have a number of different organizations in attendance, from General Motors to TIAA-CREF, GenX, American Express, Redis Labs, Accenture, King County, MarkLogic, UBS, GM, University of Chicago, Nationwide Insurance, Truven Health, Harvard Management Co., and many others. So I'll give you a few more seconds just to select your answers. Okay, and the results are in. 43.3% of you are using MongoDB, 76.7% using Hadoop, 3.3% on MarkLogic, 16.7% on Cassandra, and no one is currently using Couchbase. Chuck, I'm going to pass the event over to you.
Thank you so much, Stephen. We are excited to have you guys here, and really, I'm not just saying that. This is something that Jeff and I both is very close to our heart, and you know, I guess to really lead off, the data that we deal with today is so different than it used to be. 90% of the world's information was created in the last 2 years, and 80% of it is unstructured. So that means that we're getting data today that is different than the data that we used to get in respect to, you know, where we need to put it, how we need to report on it. It doesn't fit in these nice little boxes, these fact and dimension tables that we've built and these relational models that we've built. The data that we depend on and that is beginning to be critical to us running our businesses and making decisions about what we need to do, it's becoming so different, it's becoming so difficult to manage that we need different tools. I mean, if the data is different, the data is different. The tools that we're dealing with and the models that we have, they're 10 to 20 years old or older. So we need different tools. We need different approaches. And so I think that everyone on the call is going to be very interested in seeing what we have to present related to SlamData and how we're approaching a new analytic engine and maybe BI reporting. So I'm going to hand it over to Jeff and let him talk a little bit about where we are today in our traditional data warehouse.
Thanks, Chuck. I appreciate it. So welcome to everybody here today, and we're glad to have you, as Chuck said. So what I want to talk about now is just sort of what I refer to as the analytic conundrum. And what this is really just sort of high-level characteristics of what we've traditionally experienced in the data warehousing world and sort of where people really want to be, and when I say people, I mean companies want to be today. So if you look on the left, you know, you see some characteristics of the traditional data warehouse, and these are very high level. But obviously they're ETL-based. ETL models can be not only hard to create but somewhat brittle. And what people are looking for is a much more flexible way where they can not only get the data into the data warehouse or data hub easily, but also add new sources really on the fly as quickly as they can capture them. Another area where you see contrast is with how fresh the data is. So in a data warehouse model, the data can be stale just depending on how you built your ingestion processes. So sometimes the data can be out of date by maybe a day or two, but it can also be several days or weeks even. What we really want in today's modern data hub is fresh data. We want the data available to us for analysis as soon as we capture it, or within maybe seconds, worst case maybe minutes. In terms of your ability to query data, so in a traditional data warehousing model, you're typically limited somewhat by how you architected it in terms of what sorts of queries you can ask and how flexible that is. What we really need today, again, is the ability to ask any question over any data, no matter how complex the data is, and to do it in sort of an ad hoc fashion if needed. And then just time to market. This is one of the huge advantages of a data hub model. In traditional EDW, it can take anywhere from months, weeks, to even months, and in some cases years to deploy a full system. With the modern data hub, using some of the technologies that we'll talk about today, you can deploy an entire solution in days to maybe weeks. So those are some of the high-level characteristics. And what we're going to do now is I'm going to hand it back to Chuck, and we're going to drill down into those and really start to talk about the details behind both approaches. So Chuck, take it away.
Great. Thank you, Jeff. So what I'd like to do is I'd like to kind of drill down into a very rudimentary structure, a model, if you will, of really what our traditional data warehouses look like. And if you can visualize the center of the hub, this traditional warehouse, it's really our star schema database. And whether that's Oracle, MySQL, SQL Server, Redshift, whatever we're using to put our data into, a lot of times it's this traditional star schema structure. And in order for us to load that structure, on the left side we've got processes that we've built, and we're using all of these ETL products to extract data from CRM, all of our relational models, all of these other sources, transforming that data and loading it into the structures. It requires us to do transformations because the data we're getting or starting with, it's not in the model, it's not in the format, it's not in the structure that we need to load. So there's a lot of investment in time and energy on the front end, just getting the data into the structure. And then on the opposite end, getting data out of the structure, we've got issues and problems. We've got all the performance problems of trying to pull data or large amounts of data from our star schema structures. And we've got all these other tools that are great solutions that we have for reporting today, but they're all predicated on that model. And with the traditional warehouse, people are asking questions like, how long is this process going to take? How long is it going to take me to get this traditional warehouse built? How quickly could we make changes? What is the return on investment? 6 months in, a lot of times CIOs, a lot of times developers, directors are asking, look, we haven't seen anything. Where's our investment here? How long is this going to take? And then are we really even sure these are the right reports? When we look at this from left to right, we extract data, we transform it, we load it into a structure that's completely predicated on what our output needs to be. But if we're starting with something that we really don't know what our reporting ought to be, then we're predicating all of our efforts on BI reporting that might or might not be the perfect end result, the solution that we need. So let's do this. Now I want to kind of drill down a little deeper, and let's really look at some details about ETLs. So why is the ETL portion of this such a burden? Well, there's a lot of transformation activity that has to happen. The ETLs are structured. They're structured in such a way that we have to move the data from one format, one structure into another. It's a maintenance burden. We have to monitor these ETLs. The ETLs will go down, the files will be missing, the transformations don't happen like they should. We have other issues of we're extracting data, usually a lot of data from our other systems that we require 24/7. Sometimes we don't want to put a burden on EBS, for example, because it's a 24/7 need, and we don't want to slow those processes down, but we've got to extract the data, so then we have to push the data off into some other offloaded area to extract data from that. Then we have problems with statistics. I mean, there's so much involved in just the ETL that the investment and the return on investment is so hard to measure. It's often just viewed as something, it's just got to be done. We don't have a choice. That's just the way it is. And then we have other problems that we're seeing now, perishable insights, for example, things that we'd like to be able to make decisions about quickly. We want to know what's happening during the Super Bowl. We want to know before Mother's Day, during Mother's Day, during Thanksgiving. We might want to change some sales directions. We might want to offer some new incentive. But if we're not prepared for that, we have no time to change the ETL. We have no time to modify the loading structures into the new changes that we've made in the star schema database, and then reporting out of it on the other end becomes a real problem. So if we look at the burden of the other side, the reporting, our traditional analytic reporting is predicated, it's always predicated on the structures that we've built. And if we don't plan these structures well, we're creating performance problems for ourselves. We're creating issues of not being able to get to those perishable insights. We're missing opportunities. And, when we spend all the time and energy to build this traditional EDW, we end up with something that in the end we, realize maybe we need to go back to some of this reporting and we need to rework some of it. Well, then we're starting the whole cycle again, right? Then we've got to go back to the ETLs. We've got to load the structures that we're now building, the new facts and dimensions that we're adding to our warehouse. Over time, it becomes a tremendous burden that's difficult to manage. So what we're recommending, and what we're putting forward, is maybe a new data hub approach. When we begin to load unstructured data into something like this, we're compounding the problem, right? So how do we then take our traditional approach, how do we take this approach, and then how do we add to it so that we're improving upon it so that we can do more than just what we used to do? How can we do what we used to do plus what we want to do and what we need to do? I'm going to hand it back to Jeff, and I'm going to let Jeff kind of step us through some new approaches and concepts. Jeff?
Great. Yep, great. Thanks, Chuck. So let's look at some new approaches or different ways that we can address the problems that Chuck just outlined. So here's an example of a modern approach. In this case, what we're doing is capturing a variety of data sources. It could be traditional relational transactional data. It could be unstructured or semi-structured data. Or it could be other kinds of sources. It could be IoT data or something like that. And in this case, you're capturing in something like a MongoDB or potentially Hadoop or even another NoSQL source. And then what we're doing is directly using something like Slam Data to directly be able to query that data without having to go through and build out a whole bunch of additional infrastructure, and certainly eliminating all of the grayed out stuff on the right-hand side of the slide there, for ETL and those kinds of things. And so what this means is immediate access to the data. As fast as you can sort of ingest it into the system, you can immediately start getting analytic value out of that. Here's another example, in this case using something like Hadoop. So again, capturing JSON data, structured data from your traditional sources like RDBMSs and things of those nature into Hadoop, and then using something like Slam Data to be able to directly report against that data as it exists in the Hadoop file system. And we also actually have a secondary tool that we've introduced a while back that allows you to connect an existing BI tool like a Tableau or a Power BI or a Spotfire to that same structure. Now, I will say that with that tool, there are some limitations that come with that because it is still relying on that relational structure. So it's not strictly as powerful or as flexible as the core Slam Data solution, but certainly companies want that ability, so we provide something like that as well. So in terms of the notion of data lakes or data hubs, it's not necessarily a new thing. It's been around for a couple of years, but what really got it going was the idea of using Hadoop to capture data, really simply. You could just ingest data from any structure, any source, and just get it in there quickly. And same's true with something like a MongoDB or a Couchbase. But what was harder after that in the past was actually being able to get the data out. So we solved sort of half the problem. And that's the problem that Slam Data has addressed, where we've essentially made it much simpler to implement these kinds of solutions than what I would refer to as a first-generation data hub, where it was sort of easy in, but then you had to build a fair amount of custom coding and infrastructure and things to actually report on the data and get it out. In the case of Slam Data, we've eliminated that, so it's really as simple as being able to just connect directly to the data. So let's take a moment and just be clear and talk about what Slam Data is and what it's not. So on the left side, let's talk about what it's not. It's not a database. It's not a monitoring tool. It's certainly not an ETL tool. It isn't NoSQL or replacement for a SQL database. And it's not expensive. Slam Data is 100% open source. So let's talk about what it is. So Slam Data is an analytics engine. It is an engine specifically built to be able to directly query semi-structured data. So that includes JSON and CSV and XML and essentially anything that you can jam into these modern data sources. And you can query it directly. It doesn't in the form that it actually exists. Slam Data exposes a SQL dialect we call SQL squared. So it's very familiar for people that are DBAs and things of that nature. And what we've done with SQL squared is we've essentially enhanced it so that it has additional capabilities to deal with the kinds of data structures you see in JSON or CSV or XML, so nested data, arrays, those kinds of things. Today, Slam Data natively connects to MongoDB. Our Hadoop connector is in beta, so that's something that's sort of invitation only. It should be generally available by October. And then essentially Slam Data solves the problem of not only directly querying non-relational data structures and reporting on that and visualizing that, but it spans this huge gap that we've had in the data warehouse or the data hub model for the last several years. So let me just show you some examples of what kinds of things you can do with it. So this first one is just an example of a report, and this report was built directly on IoT data, so in this case JSON files being emitted by sensor nodes that were ingested, in this case into MongoDB, and without any changes to them whatsoever, without any kind of additional infrastructure, you simply connected Slam Data to the database, and in literally about 10 minutes or less, we're able to create this interactive report. So on the left side, you've got essentially a way to select the different nodes emitting the data. On the right side, you've got some time frames, and then you get the visualization back, and that's fully interactive for the end user. And this can be created and published out either as a link, if it's just to other people within your organization, or if you're putting it inside of an application that your external customers or users might have, you can embed it in there securely. Here's an example, and this is a little hard to read, but we just wanted to kind of give you a sense. So on the left, what you're seeing is an example of a SQL query, but what we're doing here is we're actually querying nested data. So there's additional operators you can actually see. If you go to line 5, you see sort of the square bracket wildcard there. And what we're doing is these are previous addresses that are actually stored in an array inside of a patient record, all fictitious data, of course. And you can see that we're actually returning all those previous addresses in this nice tabular format. So that's a relatively simple example, but this is the kind of query that you can do using Slam Data that you could never do using traditional SQL, or certainly not do on JSON data without a very complex ETL process. And then just one last example. So this is just showing you how you can create other kinds of visualization. This is some machine data where we're actually capturing various metrics, showing you how you can create the charts and publish those out very easily. So just some quick examples of some of the kinds of reports you can create. Everything I just showed you can be literally created, again, in 10 minutes or less directly on live data. So I'm going to go ahead and turn it back over to Chuck to walk you through and talk about how we're using this technology to bring value to our customers.
Thanks, Jeff. So I know we're sort of breezing through some of these things, and I would encourage you to post some questions in the Q&A. Jeff and I anticipated that the end of this presentation, we probably could have a healthy discussion about where Slam Data fits, where the value is, but I wanted to kind of throw some examples of where Slam Data might actually fit, what a solution might look like, and where it's been used. And so let's take, for the first example, let's take this idea of a Mongo database. Maybe you already have Mongo. You've been loading it with all kinds of data across the enterprise. You've begun to build a data lake, and you kind of have this historical data. You've been able to get data in, but getting data out is kind of somewhat of, there's a lot of time and energy involved in it. Writing the Mongo queries are not necessarily easy to do. Maybe you have a whole team of developers that know SQL. Maybe you have BAs that already know SQL. They can write SQL, and you need a good front end. Slam Data is a perfect solution for something like that. You don't have to create all of the additional structures in order to render out your visualization, your data sets. As you saw with the screenshots, it's very direct, very easy to get data out of Mongo. So what about if you're planning a traditional data warehouse? Let's say that you're involved in scoping out a whole new EDW and the whole idea of a 6 to 12 month effort. When you don't really know what your end reporting completely ought to look like, what is it that we want to report on? How do we want to structure the data? There's so many questions that need to be answered. Slam Data is a perfect solution to grab all of the data that you're going to potentially be putting into your data warehouse, put it into a Mongo database, and then put Slam Data on top of it and begin to proof out what your reports look like. Begin to build out your reporting and kind of scope out what the structures could potentially be. And you could implement a data hub like that and get a proof of concept, if you will, for a EDW in weeks and not months, and give you a little bit of a confidence of what your ROI is going to be. Give you a path to what your traditional EDW might look like. Let's say that the plan would be to build it upon some other relational structure, but you really don't know how to get there. Slam Data would be a great solution, great option to implement in just a few weeks. Maybe you're already collecting machine data. You're using a product like Splunk or Logstash or something else where you're collecting log files and you're putting them all into a tool like this, and you're using that to do monitoring and reporting. But it's not necessarily the ultimate solution. Maybe it's become too expensive. We have customers that are using this Slam Data on top of Mongo that are replacing products like this. They're putting their machine data into databases like Mongo. They're putting Slam Data on top of it, and it gives them all of the reporting, all of the things that they want to see out of that machine data. Perhaps you are invested in Hadoop, or you want to build something like a data lake or a data hub, and you want to use Hadoop. Again, Slam Data would be a great solution. Sitting on top of that, it does not require all the investment in the structures and schema structures to build. You can put it right on top of the data, and whether you're talking about, as Jeff mentioned already, CSV, XML, JSON data, whatever you have put into Hadoop, you could extract out into nice visualizations, nice data grids, export that again, a nice little subset, a CSV. A lot of great solutions there. So these are some examples of where a Slam Data Mongo might make sense. So again, just to kind of recap, why this approach? Well, it saves a lot of time and energy. It saves time and money. Scoping the whole relational star schema structure for your data warehouse, it's a lot. It gives you a pathway. It's a lot more simple. It eliminates a lot of the overhead of planning the structure, and the ETL process is far more simple. There's not a lot of transformation, if any, that you have to do. You're extracting data and you're loading data, and so it's a solution that you can get in days to weeks, not weeks to months. And so the energy involved in getting something like this up and running is far less of an investment than what it would be for the traditional data warehouse. So maybe if we gave you some case studies of where we've actually implemented something, that might help. So Jeff has some case studies. So if you will, Jeff, step through some of these with us.
You bet. Thanks, Chuck. So just a couple of examples of where this has actually been used in the real world. So first example on the left is we were working with a large government agency. In this case, the need was they needed to consolidate data from more than 5 data sources, all in very different formats, extremely dynamic information. And the main issue is they needed to be able to answer questions, ad hoc questions, in minutes to hours, not days to weeks. So it was something that literally any kind of ETL process was just not going to work for them. They actually tried to go down that road, and it just wasn't successful. And so they were able to capture the data from these multiple different sources into a NoSQL database, and then using our tool, they're able to express any kind of question. Slam Data is fully generalized, so it supports basically anything you can express within the range of the SQL select clause. So they can ask any kind of question ad hoc, and depending on the amount of data, they can get the answer back in seconds to minutes to worst case hours. It's an extremely large data set. So that was one example. And in this case, again, the data was very perishable. So they needed to be able to get the answers back quickly. Another example on the right-hand side is a global technology company. This is one of the larger technology companies in the world. And in their case, they were actually, this is a part of their business that works in the security space. And they were capturing security and scan logs from web pages, security data and scan logs from web pages. And they needed to be able to, again, do sort of complex ad hoc queries against them. As you can imagine, the data is very dense, it's very text-heavy, and it's highly variable. And they wanted a way to be able to query that data directly and to take those results and use them for various vulnerability assessments and things of that nature. And so in this solution, they used MongoDB to capture those live scan logs, and then we're able to use Slam Data to successfully query that data and create visualizations and reports from that. So that's just a couple of examples, one in the security space and one more in the government space, but both focused on sort of large, complex data needs where they're consolidating data from a variety of sources. They need to be able to ask ad hoc questions or even create reports that they can get immediate feedback from. So I'll go ahead and hand it back to Chuck to talk about
Thanks, Jeff. So we would love to answer your questions. I know that there are some that are coming in, and I think it would be healthy for us to step back a little bit and answer some questions. But one of the things Jeff and I would love to do would be to actually show you. And one of the things we thought we would do would be to say, give us your toughest data analytic problem, and let us try to solve that. We could give you a proof of concept using Slam Data and your data in potentially whatever form you have, and then see where we can take it and have that conversation. But in our view, Slam Data is really the missing piece in your data lake, data hub. It's very easy to leverage all of the skills that your team probably already has with SQL, and it does not require learning new languages, new technologies, and it gives you the ability to build some powerful reporting and dashboards. And so, with that, we can open it up for questions. And
so I see some questions in there. I see some questions in there, Chuck, and I'm happy to just start to answer some of those.
Absolutely. You know what? Thank you, Chuck and Jeff. Before we move on to questions, we do have a quick survey. You'll all see that popping up on your screen. And the first question in the queue right now, how does Slam Data differ from Alteryx or Tableau or even Pentaho?
So I'll be happy to take that. It's a great question. Alteryx, as well as Tableau and Pentaho, are great tools. I'm a fan of all of them. But let's be clear, they're strictly relational. So both Tableau and Pentaho, which are analytics tools, and Alteryx, which is sort of a data wrangling or pipeline tool, are designed to deal with strictly relational data. And so if you have a bunch of JSON data, there's no way to query that directly from something like Tableau or Pentaho. You could actually use a tool like Alteryx to reshape that data to essentially kind of wrangle it into a tabular, very homogeneous format. But that's a lot of additional work, and we've actually published a white paper that is on the Slam Data site that talks about how that can create an entirely different set of challenges, because when you try to take semi-structured data like JSON and fit it into a tabular format, you can actually lose information in that process depending on how complex it is. So that's the main difference, is our tool is designed to work natively against semi-structured or really any structure of data. It doesn't need to be tabular or in tables, and it doesn't need to be homogeneous, meaning it doesn't need to have it doesn't need to be completely uniform. It can have as much variability in the data model as the data itself has. So hopefully that answers your question.
Understood. Thanks, Jeff. Our next question, how does Slam Data establish relationships between data elements?
So I'll give a high-level answer here. I see it looks like a gentleman from IBM. I'd be happy to go into more detail. Or go more detail offline. So Slam Data doesn't require any kind of schema or even think in the sense of a schema the way we think about it in relational land. Because in NoSQL, not only many people on the call have probably heard they're sort of schemaless databases, but even the ones that sort of have some level of schema, it tends to be very dynamic, meaning it's always changing, which is sort of anathema to the idea of schema. So what we've actually created, one of the most powerful pieces of technology inside our core engine, is something called a bidirectional type inference system. So kind of a mouthful, but what it is basically we establish the data types at runtime or as they're needed, so to speak. And so we don't require any advanced knowledge of the data at all. So for example, when you dump a bunch of data into something like a MongoDB, you can install Slam Data, connect it to that database, and begin asking questions immediately, literally within minutes, as fast as you can install it, because it doesn't need to know about the data. It doesn't need to understand relationships between anything. It determines that as it's actually doing the querying. And this is a very new concept, and it's a very powerful one. But frankly, it's the future of analytics, because data is getting more complex, not less complex. And the idea that we have to shove everything into a table where we can create relationships, it's getting harder and harder and harder. So that's a high-level answer how we do it. It's a bidirectional type inference system. I will make one more comment along that line. Our technology is 100% open source. So anybody that wants to go to GitHub and look at the code, it's there. So we're not hiding anything. You can see how these things are done. It's relatively complex, but it's all there. So hopefully that helps answer the question.
Absolutely. No, thank you, Jeff. Our next question, does Slam Data provide an interface to connect data sources with SQL, like a tool?
I'm trying to think. Again, I'm not 100% clear on exactly what the question is trying to ask, but the short answer is probably no, because, again, what Slam Data talks an enhanced SQL dialect, meaning it's got things that it does mathematically and operationally that a normal SQL tool cannot understand. And so by doing that, you could do something similar to that, like our BI connector is essentially probably what you're describing, and it ends up being kind of a dumbed-down version of the core technology. So again, I'm not trying to say that in a negative way. I'm saying that you could probably use the core engine to do some of that, but it would be less powerful, strictly less powerful than what you would get using our enhanced SQL dialect and our entire sort of engine, if you will.
Understood. Our next question, one of the slides mentioned using Spark. Can you provide more details on how you'd recommend using Spark?
So we're in the process of creating our connector to Hadoop/HDFS, and we're using Spark technology to do that. And so SlamData, the way it'll work is SlamData will actually connect to Spark using their RDD, which is essentially their lowest level of connector. It's sort of the core connector versus they've got some higher level stuff called data frames. But what it will allow you to do is natively query Hadoop files, HDFS files, through the Spark framework. You'll be able to take advantage of the distributed computing nature of Spark and some of those things, but you'll also be able to use all of the not only UI and visual capabilities of something like SlamData on directly against the data you have in Hadoop. So it could be JSON or XML or CSV or a little all of it, very messy data. You'll be able to directly query that. And the SQL squared dialect that we support is actually more expressive than something like Spark SQL. Spark SQL still is relational at its core from a mathematical perspective, and so our tool through Spark is actually more expressive.
Understood. Next question. Is SlamData available in the cloud, or does it require some on-premise installation?
So right now it is software. It is open source software that needs to be installed. It'll run on any device, meaning Windows, Mac OS, or Linux. It can be run locally or as a server. The front end, the UI portion is all HTML5, so it can be accessed using any browser from any device. With that said, we have been building out a cloud instance of it. It's not yet available. We hope to have it available by the end of the year. But it's not yet available. So as of today, you would need to run it, again, either locally on your desktop or MacBook or as a server inside your enterprise.
Understood.
Or it could be run and just to be clear, it could be run in something like AWS on a virtual server that you would spin up there.
Gotcha. Thanks for clarifying, Jeff. Our next question, do you have any plans to connect to DynamoDB?
We don't today, just because we haven't had a lot of demand for that. I'm very familiar with Dynamo. I think it's a terrific database. I think the way our technology works is as follows. The core engine is able to connect to any non-relational data source or relational data source even, but it can connect to any data source. It does that through something called a connector. And we're building those connectors right now. So we have MongoDB, we have the Spark connector in beta, and we've got 2 more slated between now and the end of the year. It's probably about 8 weeks effort to create a connector. So if a customer wanted that, we could do that for them, obviously for some charge. Or if it's something that the Dynamo folks at Amazon wanted to sponsor, as I mentioned in the beginning, or several times, we are 100% open source. So any connector can be sponsored by either a company needing it or the provider of the database or whatever makes sense.
Understood. Next question. Is there a performance impact to your transactional processing when you are hitting the database directly for reporting purposes?
There certainly can be. The way we encourage people to implement this is to actually set up a replica cluster, which is a fairly simple thing to do in MongoDB or as well as in Hadoop, where you set up essentially a replica cluster that's for reporting purposes only. So think of it as a reporting database. These modern data stores, whether it's Mongo or Couchbase or Hadoop, are really easy and efficient at creating these sort of replica cluster sets. And so that's how we typically do it. If you were trying to run it against your actual same live OLTP nodes and you were hitting it with heavy reporting loads, then absolutely you're going to see an impact on CPU usage and things of that nature. So again, and to be clear, the reason for that is because we're actually pushing these queries down to the data source. One of the things that we maybe didn't make as clear as we could have is that we're not extracting data out of these data sources, whether it's Mongo or Hadoop or something else, and trying to process that information somewhere else. We're actually pushing the computation down to the underlying data source. So in the case of Spark, all of the queries will execute, inside the Spark framework that's sitting on top of Hadoop. In the case of MongoDB today, which we support, 100% of those queries are executed in the database and pushed into the database, and only thing returned when you query the data is the answer. So again, it can have an impact on your OLTP cluster if you're using that, and we recommend setting up a replica set that you would use for reporting purposes.
You want to take the next question here? How does Slam Data differ from Anaconda 2 and other notebook tools available from Apache Spark? I know we've got notebooks in Slam Data.
Well, actually, so our previous interface, I mean, you're kind of mixing questions there. We formerly had a notebook-style interface to the Slam Data engine, which is actually called Quasar. We've switched to a more dynamic interface. The one I showed in the slides allows you to create much more flexible visualizations and dashboards than you can do in a notebook interface, which tends to be linear. But again, let's separate something like an interface like Jupyter or something like that from the idea of the core analytics engine. Our primary function is to query and provide analytics, and we do it through an interface that we created that's, again, more of a dashboarding and ad hoc query tool that, as we showed in the earlier slides. But it's not just a notebook interface like Jupyter or something like that.
Okay. We've got a question here from D&H. How do end users understand what data is available for ad hoc queries? For example, I want to know how many customers looked at product XYZ on my website. How do they know what data item to filter on? A data dictionary of some sort?
Right. So one of the first things we expose in the interface when you're using Slam Data is something we call an exploration card. And what that does is it essentially, for example, if you've got a collection of documents or data sitting in something like MongoDB, you can turn on the exploration or use an exploration card, and it will actually show you all of the schema or all of the fields that are available to query, and it will actually show you the relationship between those. So if it's a nested field, it will show you that it's a nested field so that you can answer the question in that way, that you can reference it as a nested field when you're writing your SQL query. So the Explorer cell is the answer, or the Explorer card.
Explorer card, right. Okay.
Mm-hmm.
Okay, so another longer question. All these are going to you, Jeff.
Fine.
My shop is setting up a data store. My shop is setting up a data store that consists of Hadoop and Postgres. And that's the data source of a huge application. And then, so the Hadoop and Postgres are connected together, and they give them the ability to have the Hadoop results seen in the tables in Postgres. So here's the question. Mm-hmm. How can Slam Data be used in an application to generate real-time reports, graphs, and charts, maybe within the application itself?
Well, again, hopefully I'm getting this right. I'm just trying to understand the question clearly. Obviously, what it sounds like this user's doing is transferring the data from Hadoop to Postgres and then querying from that. And that's essentially the ETL process. I'm not sure how they're doing that. I don't know if they're using ETL or they've got some sort of other process that you're using. But our suggestion in that environment would be to use Spark to query to sit directly on top of Hadoop, and then Slam Data would query Spark. And it would allow you to be able to do real-time analytics on that data as soon as it's ingested into the Hadoop framework, which I assume is coming from your application to do that. It says shop. So it's setting up a data store. I'm just rereading the question to make sure I get that right. Shop is setting up a data store that consists of Hadoop and Postgres. Okay, so maybe the application is Postgres and it's dumping the data into Hadoop. So maybe I had that backwards. Sorry, this one's a little more complex. So I might need some more detail on this.
Well, what if he had the ability to actually touch Hadoop directly and then use pieces and parts of his visuals to embed those into the application, so that those controls, the excerpts that he's creating, the markdown pieces that he's creating out of Slam data would actually be, embedded portions within the application, and it touches Hadoop directly, and not even having to go to Postgres.
Yeah, no, absolutely. So I believe I mentioned earlier that Slam data is fully embeddable. So there's an entire security framework that allows you to essentially one click. We actually generate the code to embed any chart, report, graph, anything you create in the solution can be immediately embedded into an application using JavaScript or iframes. We generate all the code snippets that you would need to just essentially embed that inside your app. And it looks 100% native to your application. So as the user brings up your application and is doing all the other things they do in the application, the reporting will be powered by Slam data under the covers, but it will be completely transparent to the end user. We'll also be getting the charts and graphs and things like that. So it is designed for that use case. That actually is our primary use case. I think we have some videos on our YouTube channel that show some of that in action. Pretty basic short videos, a couple minutes long. So, the people asking this question wanted, more details. We can certainly set up a time to talk about that.
Okay. Here's another question about Hadoop and Hive. If they have Hadoop and they're using Hive right now and using MapReduce to kind of do that inter between, could they use Slam data alongside what they've already done?
Sure. I mean, it wouldn't connect to Hive. We don't talk to Hive. You could create a connector to Hive, although again, you would get sort of a handicapped version of Slam data in that scenario. Again, our suggestion for any sort of Hadoop data, our default is to use the Spark framework to connect. So, but you certainly could run it side by side with a Hive stack as well. There's no reason you couldn't.
Okay. Another question about the kinds of data, and really related to Data Hub. What are some examples of some of the kinds of data I might capture in a Data Hub?
Sure. I mean, I think what we see commonly is a combination of things. So it will be, OLTP data from an application, might be user data, customer data, transactional data, but then bringing in third-party data sources like, Yelp data or data from other APIs, Twitter data, and things like that. And then also combining that with other kinds of third-party data that's typically going to, if it's an API that's generating the data, it's typically going to be in a JSON format. We'll see IoT data also being commonly dumped in because people are trying to use machine data or IoT-level data from devices that people are using and then tie that back to the actual users and then be able to report on those in a dynamic fashion. So those are some of the kinds of examples. It's typically a combination of, again, sort of OLTP and application-level data that the company's application in question generates, but they want to bring in third-party data from other sources. Again, it can be social data, it can be IoT data, things like that.
Okay. So this is kind of along the same lines as the Data Hub. The question is, I've loaded all the data. If I have loaded all the data I was loading today into Mongo, and I use Slam data as my analytic engine, would I still need our current data warehouse solution that we've built? So that's an interesting question. Somebody actually asked me that, very very similar question just the other day, putting these slides together. So, I think that's a great question because wouldn't you say, Jeff, that once you begin to put all that data and you have minimized the effort of the ETL, putting it into something like Mongo, for example, and putting Slam data on top of it, you pretty much have the same solution that you would in a traditional data warehouse without a lot of the same effort, without a lot of the additional effort that you would do. And the question would be, I guess, how much investment you've had in your traditional data warehouse, right? I mean,
sure.
You have any thoughts on that?
Yeah, of course. And I think from my perspective, we're certainly not telling people to throw out their data warehouses. They do lots of things, and they've been around, and companies rely on them heavily. I think it's more the notion that people's analytic needs are changing, and the Data Hub solution using the technologies we talked about today allow you to sort of iterate on that process much more quickly and sort of, as you pointed out in one of your previous slides, Chuck, sort of get to that ROI question much faster. And in some cases, the answer might be there isn't an ROI here, and we need to look at doing some different things. So I think it's the idea of flexibility and agility that we're trying to drive home with this data hub versus, hey, throw out your existing data warehouse.
Right. I mean, I see the traditional data warehouse living on. I see it has very specific needs, and it's not necessarily something we would immediately throw out. It certainly has its place. Right. So,
That's right.
and
That's
a
right.
lot of companies have deep investment in that, and it's very successful for them and very capable. I think, to me, where the SLAM data solution comes in is when you need quick decisions, you need proof of concept. I mean, it's a beautiful way to just get to where you want to go very quickly, and get
That's
your
right.
answers. Quick insights.
Yes.
Yeah,
Totally agree. Totally agree. I just saw one more question pop up. Okay, yeah, let me answer this next one. Sorry, are you still there, Chuck?
Yeah, go ahead.
Okay, sorry, I heard it cut out. So, yeah, this next one, great question. So it said, essentially I've heard the knock on NoSQL's lack of joins capability. For example, we want to join some of the raw data in a defined structure hierarchy. Short answer, and then can SLAM data do joins? The short answer is yes. Absolutely. So SLAM data is designed to do joins. It fully supports all of the expressiveness of the join operator in SQL. And we support that today on MongoDB. We will support that using the Spark framework as well. And just to give the listeners today a bit of a sense for where we're going with all this technology, our eventual goal of everything we do in SLAM data is essentially the idea of pure query federation. And what that means is you'll be able to create a query using SLAM data, and it will execute regardless of where the data lives. Meaning the data you can have a piece of it in Oracle and a piece of it in Hadoop and a piece of it in Couchbase, and it will just go execute each piece where it needs to be and simply return the answer to the UI. So query federation is what companies want to be. What they don't want more of that they have today is different tool for everything, tool for their relational data and some other tool for their non-relational data and something else again for their Hadoop stack, and that's what they're trying to get away from. So yeah, we do support joins today in the databases or data stores that we support, and we'll continue on that road.
Okay, and that is all the time we have for questions today. We apologize that we were unable to get to all of your questions, but as I stated earlier, all questions will be answered via email. I'd like to thank our speakers today, Chuck Ezell, Vice President and Practice Leader, Development, Tuning, and Automation at DataVale, and Jeff Carr, CEO and co-founder of SLAM Data. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived, and you will receive an email tomorrow once the archive is posted. Plus, if you would like a PDF of this presentation, you can click on the resource icon at the bottom of your console. Now, as we stated earlier, just for participating in today's event, someone would win a $100 American Express gift card, and the winner today is Kurt Hooten. Kurt, we will be in touch via email so you can claim your prize. Thank you, everyone, for joining us today, and we hope to see you again.